For this problem, let's take a look at this power series. Summation n equals 1 to infinity, x plus 2 to the n over 3 to the n times square root of n. And we're going to determine the values of x for which the power series either converges absolutely, converges conditionally, or diverges. There are two ways of going about doing this. The first way we're going to do this is with the root test. So method number one, we use the root test. And let's take a look at the limit as n goes to infinity of absolute value of x plus 2 to the n over 3 to the n times the square root of n. And we'll take the nth root of this. So this is going to be the limit as n goes to infinity of absolute value of x plus 2 to the n to the 1 over n all over 3 to the n to the 1 over n times n to the 1/2 square root of n to the 1 over n. Okay, now this simplifies considerably. N times 1 over n is 1, so I would just simply get absolute value x plus 2 the first in the numerator. On the bottom, once again, n times 1 over n is 1, so I'd have 3 to the first. And over here, let me switch the order. This is n to the 1 over n to the 1/2, right? 1/2 times 1 over n is the same thing as 1 over n to the 1/2. Now, the reason I switch it this way is because I will now use one of the limits that I have memorized. The limit as n goes to infinity of n to the 1 over n is equal to 1. And so this becomes 1 to the 1/2, which is simply 1. So this is equal to absolute value of x plus 2 over 3 times 1 to the 1/2 power, which is absolute value of x plus 2 over 3. Okay, and so that's the value of the limit. And so the series converges absolutely when absolute value of x plus 2 over 3 is less than 1. Or said another way, when absolute value of x plus 2 is less than 3. Also, the series diverges when the same quantity is greater than 1, or when the absolute value of x plus 2 is greater than 3. Okay, so on a number line, so here's 0, -1, -2. If I go 3 steps up to 1, and -3, -4, 3 steps down to -5, in the region that I'm marking here with orange, in this intermediate region here, the series converges absolutely. Out here to the far right, if x is greater than 1, it diverges. And likewise, out here to the far left, it would also diverge. Okay, so that counts for pretty much all points on the number line except for the two endpoints, 1 and -5. And so let's worry about those two endpoints. First, now we examine the endpoints. If x is equal to 1, then let's take a look at the series again. So here's the series again. If x is equal to 1, if x is equal to 1, then I'm going to get 3 to the n over 3 to the n. So let's write that out. Summation n equals 1 to infinity of 1 plus 2 to the n over 3 to the n times square root of n. Sorry about that. If x is equal to 1, I would have x plus 2, 1 plus 2 to the n over 3 to the n over square root of n. 3 to the n over 3 to the n cancels, and so I get summation n equals 1 to infinity 1 over square root of n. This diverges. That's a p-series with p is equal to 1/2, which is less than or equal to 1. So at x equals 1, it diverges. Now, how about the other side? If x is equal to -5, then summation n equals 1 to infinity of -5 plus 2 to the n over 3 to the n times square root of n. That's equal to square root of summation n equals 1 to infinity of -3 over 3 to the n times 1 over square root of n. And that is equal to summation n equals 1 to infinity of -1 to the n times 1 over square root of n. Okay, now I see the alternating -1 to the n, so that automatically tips me off that I may want to use the alternating sign test, and indeed that's going to be helpful here. So by the alternating series test, this converges. Since 1 over square root of n is positive, decreasing, and the limit as n goes to infinity of 1 over square root of n is equal to 0. Okay, so this satisfies the 3 conditions of the alternating series test, and so I know this converges. However, it converges conditionally since we've already established that square root of 1 over n diverges. Okay, so in conclusion, so absolute convergence occurs between -5 and 1 on this part of the number line. It diverges when you're to the left of -5 or 1 to infinity, including 1. So I've established that 1 diverges. And at -5, it converges conditionally. And lastly, it converges conditionally that happens at the one number at x is equal to -5. And so here's where it converges absolutely, here's where it diverges, and here's where it converges conditionally. Okay, now if you want to stop the video here, be my guest. I'm now going to show a second way of doing this problem using the ratio test. This is not necessarily a better method. I probably think the root test is probably what's better for this problem. But for the sake of completion and for the sake of review, I'm going to redo the problem, or at least part A of the problem, by looking at the ratio test. So method number 2. And again, I should emphasize, if you want to stop the video, be my guest. However, for the sake of review, I want to do this again, just for the sake of practicing how to use the ratio test. Okay, for the ratio test, limit as n goes to infinity of, everywhere I see an n, I replace by n plus 1. So x plus 2 to the n plus 1 over 3 to the n plus 1 times the square root of n plus 1 all over x plus 2 to the n over 3 to the n times the square root of n. Okay, let's simplify this complicated fraction. So we have x plus 2 to the n plus 1 over 3 to the n plus 1 times the square root of n plus 1. Then I multiply by the reciprocal, 3 to the n square root of n over x plus 2 to the n. Okay, now let's see what happens. Limit as n goes to infinity. Let's start collecting terms. x plus 2 to the n plus 1 over x plus 2 to the n, that's just simply going to be x plus 2. 3 to the n plus 1 on the bottom, 3 to the n on top. That gives me an over 3 on the bottom. And then combine the square roots, I get the square root of n over n plus 1. Okay, and so once again, we now take the limit of this part. The x plus 2 over 3 just comes along for the ride. The limit of n over n plus 1 is equal to 1. This is a rational function. The degree of the top is equal to the degree of the bottom, and so I can divide the leading coefficients. So this goes to x plus 2, absolutely, I have x plus 2 over 3 times the square root of 1, because n times n plus 1 goes to 1 as n goes to infinity. And I get the same thing that I had before, the absolute value of x plus 2 over 3. And so I reach the same conclusion that I had before. The series converges absolutely if absolute value of x plus 2 over 3 is less than 1, and the series diverges if absolute value of x plus 2 over 3 is greater than 1. And then we have to study the endpoints, which is going to be the exact same analysis that I had before, and so I won't repeat that here. The point being is that this could have been done with either the root test or the ratio test. Both work. I think the root test is slightly simpler, but they both work, and the analysis can be done that way.